let us begin. Make sure my camera's working. Yep. So as you can see, the previous person teaching in here wrote up the big message from the last thing we covered, which is when you're dealing with compound inequalities, like two inequalities at once, if they both go together, that means you can kind of intersect the solution sets. They go together, it's like an and. On the other hand, if you have two inequalities and the solutions to those two inequalities don't have anything in common, then they're in quote-unquote disjunction. And so you have to use what's called a union to express the answer. All right, we saw both of those. We'll see more of those today as we study the problems today. But the central theme for today is the absolute value function. All right, so what is absolute value? So we're going to talk about absolute value. Equations and inequalities. All right, I'll talk to you about both today. There are some surprises in this material. All right, so first of all, definition: the absolute value of a is equal to the square root of a squared, and what that is it's minus a if a is less than or equal to 0, and it's a for a greater than or equal to 0. All right? Of course, the absolute value of 0 is 0. But the square root of the thing squared, that's a formula for it that's kind of nice. So, for example, what are properties of absolute values? Properties. The absolute value of AB is the square root of AB squared, right? Which is the square root of A squared B squared, which is the square root of A squared times the square root of B squared, which is that. So the absolute value of a product is the product of the absolute values. Right? I don't do many proofs in this class, so there you go. That's like this is a rare event. I have proved a property. Okay, so what about the absolute value of minus a? What happens there? Well, we could write that's the absolute value of minus 1 times a, right? Minus a means minus 1 times a, agree? And so that's the absolute value of minus 1 times the absolute value of a. What's the absolute value of minus 1? Well, the absolute value of minus 1 is 1, right? Because when we square, absolute value of minus 1 is 1. And so this is just equal to absolute value of a. So the property that I just showed you there, I'll write it again, is the absolute value of minus a is equal to absolute value of a. I like to refer to this property as the absolute value eats minuses property. Just gone, right? And we also have, if you have the absolute value of a over b, well, that's the absolute value of 1 over b times a, right? That's what a over b means. You can say it's multiplication of a by the reciprocal of b, another way to look at it. And so, oh, I'm sorry, I said I was going to do one proof today. So anyway, here it is. Absolute value of a over absolute value of b. I mean, I could try to derive it, but that's really kind of beside the point here, so let me stop wasting your time. So this is a property of absolute value. Absolute value of a over b is the absolute value of a over the absolute value of b. That's good to know. And then another property of absolute value, which we won't use probably, but just in case, here it is. Absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b. This is the so-called triangle inequality. But again, I don't think we'll even probably use that. All right, so these are basic properties of absolute value. All right. Let's look at a problem let's look at how to solve an equation involving absolute value, all right? So once I, well, actually, what am I doing? I have more board. Confining myself to just half the board. I've got more board to use over here. So let's look at an equation involving absolute value. So suppose you want to solve the absolute value of 3x plus 2 equals to 7. We want to solve the absolute value of (3x plus 2 equal to 7. How do we do such a problem? Well, so what does this mean? We have to think about it. Logically, there are two possibilities here, aren't there? The one possibility is that 3x plus 2 is straight up equal to 7, right? But there's another logical possibility. We could be looking for x such that 3x plus 2 equals to minus 7. See, either one of these outcomes would give us an absolute value of 3x plus 2 being 7, right? So an absolute value problem is actually two problems. It's actually two problems, related but separate. So here we have 3x is equal to 5, which gives me x equals to 5/3. There you go. And on the other side, we have what? 3x is equal to, what's minus 7 minus 2 is minus 9. So x is equal to minus 9 over 3, which is minus 3. So there are two ways to solve this equation. We could either put x equals to 5/3, or we could put x equal to minus 3, right? Let's check our answers. Check answer. Let's see how that works. So absolute value of 3x plus 2 is equal to absolute value of 3 times 5 over 3 plus 2, right? Which is what? 3's cancel, we get 5 plus 2, which is 7. Absolute value of 7 is 7. So we solved it, right? We plugged it in, it worked. On the other hand, this was x equals to 5/3. X equals to minus 3. Check it. So 3x plus 2 is equal to absolute value of 3 times minus 3 plus 2, which is minus 7. Absolute value of minus 7. Minus 9 plus 2 is minus 7. What's the absolute value of minus 7? The absolute value of minus 7 is 7, right? So as I was saying, it works. So what is the mistake students usually make with these problems on the test? You want to guess? They don't check their answers. Well, that is a persistent problem. That is true. But here, I'll show you what students do on the test. In my example too. So we got like absolute value of 10x plus 8 equals to, oh, I don't know, 20. So here's what I see students do on the test most often, the students who get this wrong. They just go, okay, 10x plus 8 equals to 20, and so 10x is equal to 12, and so x is equal to 12 over 10, so x is equal to, like 6/5, right? And then they're like, okay, I found an answer, done. What they've done is ignored half of the possibilities, right? So when one of these problems, if you don't get two answers, odds are you're missing half the story, all right? So that's half of the solution, because we also have to solve 10x plus 8 equals to minus 20, right? And what does that give me? 10x equals to, let's see, minus 20 minus 8 is minus 28, right? So x is equal to minus 28 over 10. And if you want to simplify the fractions, I guess we could. It's, what, minus 14 over 5? Or if you like a decimal, minus 2.8, you know? I don't know, whatever. It's all good. Now, some of you might be like, I don't want to solve two problems. I want this to be one problem. Is there some notation we could use that would make this look like just one problem? There is, but it's dangerous. All right? I mean, it doesn't have to be dangerous, but here I'll show you. So if I want to solve 10x plus 8 equals to 20, right? Absolute value. Another way I could hack at this, I could solve this, would be to use the plus minus notation. So this means that 10x plus 8 is equal to plus or minus 20. And then that gives me 10x is equal to plus or minus 20 minus 8, which gives me x is equal to plus or minus 20 minus 8 over 10. And then you, at the end of it, put in what plus does and what minus does. And that gives you the two answers, right? Which, of course, is what we found are two ways, you know? So that's another strategy you could use to solve these if you like. But I think students tend to have better success when they just write down both paths like that and stay away from the plus minus. The plus minus notation, yeah. All right, so solving equations with absolute value, pretty easy. Really not too bad. It's just twice of what we already know how to do, right? Not too bad, really. Absolute value inequalities requires more attention to detail. So I think to start with, we should try to understand what is the absolute value of a mean geometrically. So what is its meaning geometrically? So here's 0, right? Here's 5. The absolute value of 5 is equal to 5. What's that tell you? And how is it related to, say, here's 0? Well, here's 0. Here's minus 5 over here, right? And the absolute value of minus 5 is also equal to 5, right? What is this? What is absolute value, really? It tells you what? It tells you that the distance, right? This distance is 5. This distance is also 5. So absolute value of a quantity is the distance of that quantity from the origin on the number line. So that's another way we could say absolute value of A is equal to the distance from 0 to A on number line. Does that make sense? So, example 4. What if I wanted you to solve the absolute value of x, right, is less than, what does that say? In terms of geometric terms, that says that the distance from 0 to x is at most 2 units. Not even 2 units, right? Less than 2 units. So if I drew a picture of it, we got minus 2 over here, we got 2 over here, right? 0's in the middle, and so like x has got to be in here somewhere, right? In other words, this is equivalent to minus 2 less than x less than 2. See, because we know from just basic geometric thinking that the solution's got to be in here somewhere, right? Which is equivalent to this compound inequality. So the solution is what? In interval notation? Minus 2 to 2. The solution is minus 2 to 2. Right? And let's see here. And I can apply the same principle to more complicated expressions, right? Like example 5. I could think about something like absolute value of 3x plus 1 less than 4, you know? If you want to, you could think about this by making a substitution, right? You could think about this thing being a, right? And so we got like absolute value of a less than 4, right? So what does that mean? That means if you drew a number line, like the a number line, that, you know, a is somewhere between 4 and minus 4, right? So we could say minus 4 is less than a is less than 4. That describes the solution here, right? But we don't care about a. Is just something we made up as a discussion tool, all right? We're actually interested in x, so let me write down what we're really facing here is minus 4 is less than 3x plus 1 is less than 4. That's actually the problem we face. But where that's coming from is the idea that the distance of 3x plus 1 has to be less than 4 units from the origin. All right, which means it can go plus or minus 4 either direction. How do I solve that? Well, we looked at these a little bit last time we met. I can subtract across, right? So I subtract 1, minus 4, minus 1, less than 3x, plus 1, minus 1. So the 1's cancel, right? Less than 4 minus 1. So we have minus 5, less than 3x, less than 3. All right. And then divide by 3, right? Divide by 3. Dividing by positive number, I don't switch the inequalities, right? So minus 5/3 less than x less than 1. 3 over 3 is 1. So what's the solution? Solution? In interval notation, minus 5/3 not included to 1 not included. There you go. Let me work another one of these problems, but this time without the a. We don't have to write down. That a was I'm just trying to explain to you the logic with that a I wrote down there. We don't have to write the a for these kind of problems, all right? Suppose we're solving absolute value of 3 minus 4x is less than or equal to, you know, I don't know, 10. So what does that mean? That means that we're at most 10 units from the origin for the quantity 3x minus 3 minus 4x. So I can straight away from this go to minus 10 less than or equal to 3 minus 4x less than or equal to 10. That is equivalent. So when we're unwrapping an absolute value inequality, It gives us a compound inequality when it's less than or equal to. All right. It gives us conjunction, as they call it. Now what do I do? How do I solve that? To get rid of the 3, what should I do? I should subtract 3 across the inequality, right? Subtract 3. Right, so minus 13. Ooh, now I've got to be careful. I've got a minus 4 multiplying the x, right? So I divide by minus 4. What do I do? It flips, right? So we get minus 13 over minus 4 greater than or equal to minus 4x over minus 4, right? Greater than or equal to 7 over minus 4. Let's clean that up. This is saying 13 over 4 is greater than or equal to x is greater than or equal to minus 7 over 4, you know? We prefer to write inequalities using less than notation. All right? So any greater than statement we can convert to a corresponding less than equation, which is better because we read number lines left to right and we write intervals left to right, like the ordering of numbers. Like you might be tempted to say that the answer is 13, and I see this on tests sometimes. Like some students will write this down as the answer. That's not the answer. See, because the more natural way to write this is minus 7/4 less than or equal to x less than or equal to 13/4, right? So put the bigger number to the right and use less than notation. Then I can tell you the answer is straight up minus 7/4 to 13/4. Now they're both included this time because we have equality, right? So this was, we don't write, when we write an interval, the number on the left has to be smaller than the number on the right as they appear on, like, they have to be the same order they appear on the number line. Let's say that, you know. Does that make sense? All right. So we can do these all day long, right? If you have absolute value of something less than or equal to something, we unwrap it as a compound inequality like this, all right? However, what happens if instead of having less than, we have greater than? So what happens? I want to solve absolute value of x greater than 9. What would that mean in terms of a number line picture? What does that say about x as it relates to the origin on the number line? That says that the distance from 0 to x is at least 9, right? So if I drew a picture of it, here's the origin, right? Here's 9, here's minus 9. It says x could be like over here somewhere, right? Right? For example, it could be equal to 9. Oh, wait a minute, it couldn't be equal. I better put a circle there, right? But how about minus 10? If x is equal to minus 10, well, absolute value minus 10 is 10. Is 10 greater than 9? Certainly. So we could also have any x's over here, right? So the solution to this has got two pieces. It's either got x less than minus 9 or x greater than 9. And you cannot put these together as one single three-part, like two, you can't write it together like we did here. These are not the same x. They cannot be the same x. These do not go together. They're disjoint, right? So the answer here is minus infinity to minus 9 union 9 to infinity. I cannot stress this enough. There's a wide gulf between the less than problem and the greater than problem here. The solution is really quite different. All right. Here we'll work another one. If I have the absolute value of 2x plus 2 is greater than 4, right? This means 2x plus 2 is less than minus 4, or 2x plus 2 is greater than 4. See, because the distance of 2x plus 2 has to be either has to be at least 4 units away from the origin, right? Which means either that is less than minus 4 or it's greater than 4. And then we solve these, you know? So I've got 2x is less than minus 6. I've got 2x is greater than 2. This gives me x is less than minus 3, and x is greater than 1. So what we get, answer, minus infinity to minus 3 union with 1 to infinity. In interval notation, there's the answer for you. Example 9, absolute value of 10 minus 3x less than 17. Excuse me, greater than 17. Greater than or equal to 17. There we go. How should we solve this? So there are two cases, right? The one case is 10 minus 3x less than or equal to minus 17, or 10 minus 3x greater than or equal to 17. So when I want to solve the one on the left, like what I like to do is to add 3x to both sides and to add 17 both sides. Basically, I'll take this and reorder it as this, right? This is 10 plus 17 is less than or equal to 3x. Do you guys see what I did there? So I moved the 17 to the other side and the 3x to the other side, changing the minuses to plus because I moved them from one side to the other, right? Basically, I'm just adding 17 to both sides, and I'm adding 3x to both sides. So that's equivalent, right? The other one, I've got 10 minus 17 is greater than or equal to 3x. Let's see here, clean it up a bit. That's, what, 27? Less than or equal to 3x. And over here we have minus 7 greater than or equal to 3x. Now, divide by 3, right? Which does not change the inequality because we're dividing by a positive number. And we get what? 27 over 3 is 9, yeah? So 9 is less than or equal to x, or minus 7/3 is greater than or equal to x. Now, I think it's healthy to kind of rewrite these. I like to flip both of these. I like to look at these as x is greater than or equal to 9, right? Or what? Or x is less than or equal to minus 7/3. See, because then I can more easily see that this is 9 to infinity. That's that part of the solution. And over here, we've got minus infinity to minus 7/3. X is, X satisfying this is in this set. X satisfying that is in that set. So what's the solution overall? We got to put these together. We use the union. So we do, I'll write so minus infinity. It doesn't matter, like, which one of these you write first. It would not be wrong to write them in the opposite order, but we do need a union, and that's it. Example 10. Kind of similar problem. 10 minus 3x, absolute value, less than 17. How should we solve that? All right, so again, this is less than. So that means this was 1. We can say minus 17 less than 10 minus 3x, right? Less than 17, because it's the less than problem. Then subtract 10, minus 27 less than minus 3x, less than 7, right? Subtracting 10. Now divide by minus 3. Minus 27 over minus 3 greater than minus 3x over minus 3 greater than 7 over minus 3, which we can rewrite as minus 7/3 less than x less than 9. So what I did in the final step is just to rewrite greater than as less than instead, because that gives us a more natural statement of the answer. And so what's the answer then in interval notation? The solution is, what's the solution? Yeah, minus 7/3 all the way over to 9, both not included. So my question to you, how are examples 9 and 10 related? If I draw the answers to both on a number line, what's it look like? So first of all, the answers to example 9, they're like this, right? Where's the answer to example 10? If we picture it on the number line, where is it? Oh, sorry to those of you at home, I forgot to pan over. It's just it's a what? It's the negative? You mean it's like...
Is it like
in the middle space, right. So minus 7/3 to 9. And of course I'll draw circles to indicate it's not including those points, right? But look at it. You put those answers together, it's everything, right? Which makes total sense, because if you think about it, either 10 minus 3x is less than or equal to 17, or, excuse me, it's greater than or equal to 17, or it's less than 17. Those possibilities are inescapable for any x. It's either one case or the other, which is why we cover all real numbers with the answers to both of these problems. So, Keep an eye out for that on my test. If I ask two questions which are very similar, there's a chance that they're complementary like this. Like I did this last year. I have one problem that's greater than or equal to, another problem that's less than. If you look at them, if you understand this principle, you can just write down the answer for the other one once you know it, because you know that if this is the answer when it's greater than or equal to, well, what's less than or equal to? It's everything that's not in this set, right? Which is, by logic alone, minus 7/3 to 9. So, but anyway, it's not a lot of work to write down these steps either, so whatever. But it's not surprising what happened. It's not surprising at all. All right, let's look at some more problems. So what's the overall theorem? If I had to summarize what we just did in these examples, here's the theorem. The theorem is just this. Number one, the absolute value of A less than some number, let's call it epsilon, is the same as like minus epsilon less than A less than epsilon, all right? And number two, if you've got something like A greater than epsilon, that's interchangeable with A being less than minus epsilon or A being greater than epsilon. So that's a summary of what we've done in the last like 5 or 6 examples. So let's see if we can solve some other problems that are in the homework from this section. All right, so, or the book actually. So another problem is this. Solve absolute value of x plus 8 equals to absolute value of x minus 9. Example 11. Actually, minus 5. I want to put a minus 5 here. I'm trying to... This is an example from the text, but... Okay, so what does this mean? There are really two possibilities, right? Either you got x plus 8 equals to x minus 5, or you've got x plus 8 equals to minus x minus 5. Now, if you're a stickler for the logic here, really both of the absolute values could be plus or minus, right? But if you think about it, the patterns are what? I'll draw the patterns out. You could have plus plus, you could have plus minus, you could have minus plus, or you could have minus minus for these. And if you think about it, if they're both plus or if they're both minus, both pluses, both minuses, that gives you this. If the pattern were plus minus or minus plus, either one of those gives you that. So we don't have to worry about doing plus minus on both of the absolute values. It suffices to just make this plus and minus to give you the two equations. I think logically you could imagine 4 different cases. It's just that 2 pairs of those cases are together. So anyway, we solved these. What do we got? Oh! Ooh! This one's hard to solve. Subtract x from both sides. What do you got? I got 8 equals to minus 5, right? Which, yeah, even the federal government can't make that happen. Like, so there's no amount of money that you could print to make that true. This is false, right? So what's that mean? There's no solution in this case, right? How about the other case? Well, there we're in luck because we got 2x equals to what? 5 minus 8. Notice that this is minus x plus 5, right? Because the minus minus gives you a plus, so which gives me what? 2x is equal to minus 3, so x is equal to minus 3/2. So there is just one solution to this problem. So earlier I said there's going to be two solutions to problems involving absolute value, right? Got to be careful with that, right? So there could just be one solution if this happens. But the kind of problems we solved at the start of class don't have this happen. Those are a different kind of problem. All right. So next let's look at some simplification problems. We're supposed to simplify, leaving as little as possible inside the absolute value signs. All right. So let's look at some simplify. What'd I do? No? Okay, yeah, of course. See, if I do something funny, I need to know what it is so I can do it again. It's important for me to keep a record of these things. Oh man, I forgot to pan the camera back over there again. Ay. Sorry, people at home. Hope you learn your lesson. Come to class. Well, anyway, not really. No, do come to class. But I know some of you have real reasons to not. So here we go. Let's see here. There we go. A good set of problems to try. So I took these all from like problems 1 to 16 in section 1.6. All right. We're supposed to simplify and, you know. Okay, so this is what? This is 9. Well, I'll write out a middle step. All right, this is absolute value of 9 times absolute value of x using one of the properties. But what is the absolute value of 9? Well, it's just 9, right? So we can just write this as 9 times absolute value of x. Right? How about the next one? Simplifies to what? Okay, yeah, absolute value of minus 26, okay. Times absolute value of x, which then simplifies to? 26. Yep, just that. There we go. Let's see this next one. So if you don't mind, I'm going to stop writing down all the steps. I'm just going to say this is 20 times the absolute value of x squared, right? You could like write that. This one is absolute value of y divided by 3. So you can pull the 3 out like that.
So why wouldn't the 3 be in that?
Well, you could do that. I mean, that, yep, but that's equal to. So this is one of the properties of absolute value. The absolute value of a fraction is the fraction of the absolute values, but then absolute value of 3 is 3.
That makes sense.
And then this one here, we can simplify inside the absolute value before we do anything. Like 12 is what? 3 times 4. So this is really, and y cubed over y is y squared, right? So this is really y squared over minus 3, right? Does that make sense? Because y cubed. Yeah, I haven't got rid of the absolute value yet, but next we'll use this is absolute value of y squared over absolute value of minus 3, right? Which is absolute value of y squared over 3. So the problem is written in white, and the solution is in yellow, and what we're doing right now. So we're just simplifying using the absolute value properties. And so, again, we're going to simplify inside the absolute value before we, so like 5, x cubed over x is x squared, right? And 25 is 5 times 5, so this simplifies to like minus 5, right? So we get absolute value of x squared over absolute value of minus 5, which, of course, is absolute value of x squared over 5. Fun fact, something that's sometimes useful. I don't know if it matters to us or not, but fun fact. Absolute value of x is equal to plus or minus x. Right? So what's the absolute value of x squared equal to? And I mean this, absolute value of x quantity squared, like that. Well, this is equal to plus or minus x quantity squared, right? Now, what happens if you square plus? Like x times x is x squared, right? What happens when you square minus x? What's minus x times minus x? Yeah, it's exactly, it's x squared. The minuses cancel. So it's kind of a funny thing, but the absolute value of x squared is x squared. Which, to be further annoying, is in fact equal to the absolute value of x squared. How do I know that? Because x squared, could x squared be negative? Not for real x, right? As long as it's a real number, if you square it, whether it's positive or negative or 0, it can't be negative when you square it. So that means x squared is equal to absolute value of x, because a non-negative quantity is equal to its own absolute value. So what does this show you? This shows you could actually simplify these answers further, right? Like you could write this as y squared over 3, or you could write it as the absolute value of y squared over 3. Those are also legitimate simplifications. Now, your text seems to take the answer to be the first one I wrote. Oh, no, actually, excuse me, the text the text does want the answer to this to be x squared over 5. It actually is looking for that. You might need to make that simplification in some of your homework. So it's pretty simple. If you're looking at absolute value of a square, you can just drop the absolute value. That's what it boils down to. So, oh, sorry, didn't mean to go over. My bad. That's pretty much it for section 1.6, though. So, see you guys.